In this lesson, we're going to look at exact values. Now, in higher maths, you're expected to know the sine of 30, 45, 60 and 90 and cos and tan of these values and so on, and 0 as well, without the use of a calculator. There are two techniques to memorising them. We have the first technique, which is the table here in front of us. I prefer this method, but it doesn't mean you should go with this method. To get the 0 values, the sine of 0 and the cos of 0 and the tan of 0, I just think of the graphs. So the sine wave starts at 0, the cosine wave starts up at 1, and the tan graph starts at 0. So these values I can get from the graphs. The same with 90 degrees. From the graph, sine of 90 is 1, the cos of 90 is 0, and the tan of 90 is not defined, it goes shooting straight up into the air. So I want to concern myself with these values in the middle, 30, 45 and 60. If your graph works okay, these values here should be fine. So if we look at sine first and these values here, in fact we'll just take these ones, and I look at the cos of 30, 45 and 60, I should be able to see a pattern here. The sine of 30 is a half and the cos of 60 is a half. The sine of 60 is root 3 over 2 and the cos of 30 is root 3 over 2. And the sine of 45 and the cos of 45 are exactly the same. So if I learn these values for sine going this way, then I can automatically get the cosine values of 30, 45 and 60 if I think opposites. So I think sine of 30 is the same as the cos of 60, sine of 60 is the same as the cos of 30, and I can get my values just being the same. So that takes care of these first two, if you can manage to memorise these. With the tan, I think of just root 3 values. You can see root 3 here and root 3 here. Tan of 45 is 1. Again, you can get that from the graph or just memorise it. People generally know this. The tan of 45 is 1, because it's an easy number to remember. And if you think of the bigger tan value is the tan of 60, and that's going to be root 3 over 1, if you like. And the smaller value is tan of 30, which is 1 over root 3. That would have to be smaller than root 3 over 1, so you flip it if you like. This is one way to memorise your exact values. Some people don't like this and think it's a bit confusing, so they go for the next technique that I'm going to show you. The next technique in how to get all your exact values between 0 and 90 is to use two shapes. The first one's an equilateral triangle with sides all of 2. If you half the triangle, then this side here will be 2 and the bottom side will be 1. Because in an equilateral triangle all the angles are 60, this means that this angle here is 60 because that's this one, and we'll split the top angle in 2, so it's going to be 30. Now if we do a bit of Pythagoras to work out this side here, then you've got 2 squared plus 1 squared, 2 squared subtract 1 squared, because that's a hypotenuse, so 2 squared subtract 1 squared is 3, and then square root it, and you get root 3. Now by applying some SOHCAHTOA, your trigonometry and the right angle triangles, we can get all the exact values. So the sine of 60 is opposite over hypotenuse, so root 3 over 2. The cos of 60 is adjacent over hypotenuse, so cos of 60 is equal to 1 over 2, which is half. The sine of 30, which is up here, and this would be your opposite this time, which is 1, and your hypotenuse would be 2, so it would be a half, and so on. You can get all your sine and your cosine values for 30 and 60. But it does leave out 45, so we have to go down below to get our 45. You can get tan here as well, actually. The tan of 30 is equal to opposite over adjacent, so 1 over root 3. But to get your 45 degrees, you think of a square, side 1. So, and then we split that in 2. So if we split that in 2, we get our 45 degree angles. The bottom here will still be 1, and we'll have 1 up here. again, Pythagoras, but this time to work out the hypotenuse we add them. So the square root of 1 squared plus 1 squared is root 2. And you can get all your values now for sine 45. So sine 45 will be opposite over hypotenuse, 1 over root 2. Cos 45 will be adjacent over hypotenuse, 1 over root 2. And tan 45, opposite over adjacent, 1 over 1. Whichever way suits, a wee sketch of these diagrams helps you, or you memorise the table. One way or another, you need to try and learn your exact values between 0 and 90 degrees.